Okay, so if you're not sure how to solve for omega, which is the maximum angular velocity, and I can show you how. So now we have five scalar equations. Um, all you need to do is plug in this equation number 5 into equation number 4. So you can get rid of that variable Vg. So your Vg gonna turn to something with expression of omega. So instead of this equation, you're only gonna have one unknown, which is your omegas. Omega. The rest of the variables are given. We know mass, we know g, we know h1, we also know ig, we know h2. So that's how you solve for um, omega. Okay, let's do that. So plug in number 5 to number 4. 1/2 mass times plug in this expression, omega times d squared plus 1.5 d squared divided by 2 squared plus 1/2 ig omega squared minus mgh2. Okay, so here we substitute Vg, and now we can take this square into this parenthesis. Omega squared times d squared plus 1.5 d squared divided by 4 plus 1/2 ig omega squared minus mgh2. Okay, here we have omega squared, omega squared. We can put all the omegas on one side of the equation. So we have omega squared, 1/2 mass times d squared plus 1.5 d squared divided by 4 plus 1/2 ig equals, you can throw this term to the other side of the equation, mgh2 minus mgh1. Okay, so now we have this expression. We can divide both sides of this expression. Isolate omega. Omega equals mgh2 minus mgh1 over 1/2 mass d squared plus 1 d squared plus 1/2 ig. Okay, now we have a more condensed expression for omega squared. We can take out that square, take square root on both sides of the equation. We're going to end up with positive negative, which makes sense because this rectangular plate going to swing like that. So omega can be positive, can be negative. Depends on the direction. All right. Then we can plug in what is H2, H1, and Ig into this expression. That would be your final answer for omega. All right. Thank you for watching. Hope you learned something.